Saturation relates to our limits on solubility. When we have something that is soluble, or even something that's only slightly soluble, or even something that's pretty much insoluble, okay, the temperature of our solvent matters. Generally speaking, solids and liquids, when we increase the temperature of our solvent, we are going to increase the solubility, okay? Typically speaking, increasing the temperature increases the solubility, which means we can get more to dissolve in a given solvent at a higher temperature. Now we say typically speaking because if you look over here, this one right here, that one, the solubility goes down. But it's the exception rather than the rule. When I look at the sodium nitrate, potassium chloride, sodium chloride, potassium chlorate, they all increase in solubility with increase in temperature. Now the other thing though is it's not a cut and dry relationship. For every single solute, the increase in solubility is different. So some of them barely increase in solubility, other ones sharply increase. Some have a linear increase in solubility, some have a more curvaceous increase in solubility. So the increase in solubility with temperature depends from component to component, substance to substance. There's no rule that says this is the proportionality for the increase. It depends on the particular thing you're looking at. Okay, and then remember with gases, increasing in temperature lowers the solubility. So the two blue lines on here are two gases, and you can see that those absolutely go down with the temperature. So we can get three different types of solutions. We can get a saturated solution, an unsaturated solution, and a supersaturated solution. Saturated just means we've reached the limit of solubility. We can't get anything more to dissolve. If I try to dissolve anything else, it's just going to sit there. Okay, so if I've reached my solubility, I put more of my solute in there, it's not going to do anything. It's just going to sink to the bottom. Unsaturated, we're not at the limit of solubility, which means that if I try to dissolve more into my solution, I can get more to dissolve. I add some more to it, I swirl it around, it dissolves. Now, supersaturated, these are really interesting solutions. These are very unstable, and not every solute we can exploit to a supersaturated solution. What happens is we heat everything up, okay? Higher temperature, higher solubility. So we get it to dissolve. Now, usually what happens is as you cool that solution back down and you get to a lower temperature, the excess solute will crash out, precipitate back out of solution. And so you're able to get your solute back out. This is the way we used to purify things. However, some solute solvent systems, when you heat them up and then you cool them back down, the excess does not come back out of solution. So now we're at a lower temperature, but we've dissolved enough for a higher temperature. And so this is where we get a supersaturated solution. So we have more than the normal amount of solute that will dissolve at a given temperature. These are really unstable. It doesn't take much to get stuff to crash back out of a supersaturated solution. Okay, and so you can see my unsaturated solution, no excess solutes there. My saturated solution, we have some excess sodium chloride left over. Now, even in saturated solutions, I said that, your excess just kind of sits there. Well, that's what it looks like to our eyes. But what's actually happening inside the solution is it's dynamic. Everything's moving around. Liquids move around. They don't just sit there. And so what happens is all these particles are bashing into each other. And so if I have an ion that's dissolved, and then that ion hits my undissolved piece, a new ion will pop off. And so you've got this dynamic situation where it's in equilibrium with each other, where the rate of stuff crashing in equals the rate of stuff redissolving. And so it's not just super boring, it sinks to the bottom. You won't get any excess to dissolve in, you'll just be exchanging which particles are dissolved and which particles have crashed back out. And then our saturated solutions, again, they're super unstable. And so if you do something to mar the inside of your glass, or you add in a seed crystal, so i.e. another piece of that solute, once it sees that, now it goes, wait a second, there's too much of us dissolved. We're not supposed to be in here. And then they all just start crashing out from where that seed crystal drops in. It's really cool to watch a supersaturated solution crash back out. So again, everything has limits of solubility. So sodium acetate, if we're at 75 degrees Celsius and 115 grams of our sodium acetate per 100 grams of water, so 100, 110, 120, so about here. All right, so our 75 line goes up here. Our 115, we go over this way. So I'm not quite right in the middle there, but basically we should be right on that line of saturation. So that's where we're saturated. So at 75 degrees Celsius, we shouldn't be able to get any more sodium acetate to dissolve into our water. All right, here's another one. Now we have 50 grams of our sodium acetate at 75 degrees Celsius. So we're here, and then we're at 50. Okay, so we should be right in here. So this one should be unsaturated. And so every solvent system will have their own graph like this for understanding where your limits of your solubility are.